Hi folks, I had a request for a video on changing the form of a quadratic equation. So we'll start with the easiest ones, which would be from vertex to standard or factor to standard. And those are easy because it's just a matter of expanding the expressions and that will automatically give you standard form. So if we take a look at this example in vertex form, just a matter of completing the operations in the correct order. So again, we have to follow BEDMAS here, so we have to complete the exponent first. So please do not make the mistake of expanding the -2 with the x plus 5. You first have to take care of the exponent 2. So I'm actually going to rewrite x plus 5 times x plus 5. At a certain point, you can just expand this without having to write it out, but I'll do that just to be sure I get it right. So -2, and then we've got x squared, 5x plus 5x plus 10x. 5 times 5 is 25. And then, of course, the -3. The second operation we have to complete is this multiplication here. So I'll expand that. So -2x squared minus 20x minus 50. So I just multiplied this to every term in the bracket, and then -3. And lastly, we just have to simplify what we can simplify. So -2x squared minus 20x, and then -50 minus 3 is -53. Okay, and there you have it. Now we've got standard form, and of course we notice that the a value in standard form is the same as the a value in vertex form. Okay, let's take a look at factored to standard, and again, it's just about expanding. Now, I could multiply 4 times x minus 3, but since multiplication is commutative and I can and associative, in fact, I can multiply any terms first. So I'm going to first multiply the two binomials. I usually find that easier. So here, x squared 7x minus 3x, so that's plus 4x, and then -3 times 7 is minus 21. And now it's just a matter of distributing the 4, so 4 times x squared, 4x squared, 4 times 4x plus 16x, and then 4 times -21 is minus 84. And yet again, we see that the a in factored form is the same as the a in standard form. Okay, for our next example, we'll start with standard form and go to vertex form. And the process we use for doing that, of course, is to complete the square. So let's just do a quick example of completing the square. So we remember that in order to be able to do that, we need a coefficient of x squared of 1. So we just factor out whatever the coefficient of x squared is, and we do that from the first two terms. Okay, so in this case here, we have to factor out a 3, and we're left with x squared minus 8x, and we leave the -1 for later on. Okay, and now that we have inside the bracket a coefficient of 1, we can go through the process of completing the square with the expression in the bracket. So x squared, and we need to create that form that'll factor a perfect square. So we need the middle term to be 2 times our h value, which in this case here would be 2 times 4, okay, x, and then we have to add and subtract the h values. So we're going to add 4 squared, the square of the h value, so we have to add 4 squared, 16, and then because we're putting in something new, we also subtract it to make sure that we don't change the value of the expression. Okay, and then of course there's the -1 on the outside. And now we've created the form necessary to get our perfect square, because the first 3 terms here factor to x minus h, which in this case here is 4 squared. But of course we still have this -16 hanging around, still in the bracket. And now we just simplify to put it in vertex form. Okay, so we're going to distribute the 3 to both of these expressions. So 3 times the first, 3 times x minus 4 squared, and then 3 times the second, 3 times negative 16 is minus 48, then minus 1, and finally we can incorporate that last number. So 3 times x minus 4 squared minus 48 minus 1 is minus 49. And there we have it. We've gone from standard form to vertex form, again by successfully completing the square. Okay, for our next example, we'll again start with standard form. This time here we want to put it into factored form. Now, at this point, we only have one way to do that, and that's by factoring the quadratic expression. In this case here, it's a trinomial. Of course, it could also be a difference of squares. At this point, this is our only method of doing that. So we have to hope that this is factorable. If it's not, at this point, we can't do anything. We will see in the next unit how there is another way to achieve this. So here I've got a trinomial with a coefficient of 2. And again, I could go through the process of testing out a bunch of possible scenarios. But as you get more comfortable with factoring, you'll start to notice, well, if you do 2 times 4, that's 8. And we have 7. So that looks pretty promising. So I'm going to right off the bat write this as 2x. And then, of course, that means this one here will be x. And I'm going to want to multiply the 2 by the 4. So I'll put the 4 here. And then here the 1, so here 8. And 1 will help me get 7. Since I need positive 7, it'll be plus 4. So 2 times positive 4 is 8. And then minus 1 times x, so 8x minus x gives me my 7x. Now, this is where things get a little interesting, because in terms of actually using the factorization of a quadratic, usually to find the zeros, that's really as far as you need to go. Okay? Because if you were finding the zeros, if this was equal to 0, you'd just say 2x minus 1 could be equal to 0, or x plus 4 could be equal to 0. So, unless you're necessarily looking for factored form, this is where you would stop. Okay? However, when you think of factored form, this number here, the a value, should be the same as the a value in standard form. So essentially what you need is you need to put it into the form, if you recall, x minus m, x minus n. In other words, the coefficients of the x's must both be 1. So in order to achieve that, I'm going to have to factor out a 2 from this first binomial. So I'll do that, factor out a 2, and I'd be left with x minus, well, 1 divided by 2 is 1/2. And this would be factored form of the equation. And again, here we see that the a values are indeed the same. But I want to stress that in most scenarios, unless you're specifically looking for factored form, you can leave it here, because normally you're just looking for the zeros, and you can solve it from this form here. So the last scenarios I'm going to deal with are going from vertex to factored, or factored to vertex. And the truth is, there is no direct way to go from vertex form to factored form, or factored form to vertex form. So what you do is you take a little detour along the way. Is here, first you would take your vertex form, expand it to get standard form, and then from there you factor it to get your factored form. Okay, and you do the exact same thing in this scenario here. Is you take your factored form, you expand the expression to put it into standard form, and then you complete the square to put it into vertex form. So I won't actually do examples for these, since I've done this in previous examples. So again, in either of these scenarios, vertex to factored or factored to vertex, you first make a stop at standard form in each case, and then you complete the process using the appropriate method. And there you have it, how to go from any one form of a quadratic function to any other form.